So students, we are back with our operating system paper, and in the first session we have learned about the basis of operating system, and I hope you know what is an operating system and what is the need for an operating system, and you know the basic functions of an operating system. Now, in this session, we learn about the computer system operation. Before learning about the computer system operation, we must have a basic idea about the components of a computer. The basic components, as you know, the basic components of a system contains CPU, memory unit, as well as the input output devices, the usual devices as keyboard, mouse, printer, monitor, disk, etc. For any general purpose computer system, it contains more than maybe one CPU or more than one processors. For simple personal computers, there may be making use of a single CPU, or for any other systems, mainframe systems makes use of multiple processors at the same time. Multiple processors may be executing simultaneously for mainframe systems, but for personal computers there may be a single CPU and a memory unit along with other peripheral devices, that is the input output devices, and all these the CPU and the all the other devices will be connected using a common bus. And in addition to this, in order to control all the activities of this disk or other devices connected to the system makes use of device controllers. So the device controller is also a software which is in charge of controlling the specific type of device. The function of the device controller is to control or manage the activities of the other devices, specific device that is connected to the system. And remember, all these device controllers and the CPU are all for all the time, these are all functioning or executing simultaneously for all the time. And to these CPU as well as the devices, multiple devices may be competing for the memory cycles, as there will be only one memory unit in a system, and when this system contains more than one processor, there may be a competition for memory cycles. In case of many devices accessing the same memory location, there may chance for competition of sharing memory or for accessing memory information. In such cases, memory controller, it's also a program, a memory controller is there which is used to synchronize access to the memory. So the memory controller provides access to the memory location for each and every device in a particular schedule. For that, we make use of that memory controller. So the device controller is in charge of managing the devices connected to the system, and the memory controller is in charge of synchronizing all the devices access to the memory. So these are all basic components and the basic operation of a computer system. And before starting with the operating system, we need to know that whenever we switch on a computer, it starts executing a specific program called the bootstrap program. Whenever we switch on the system, for any computer to start running, it needs to have an initial program to run, and the execution of this initial program is called the bootstrap program. This initial program that is to be executed whenever we switch on a computer is called the bootstrap program, or it is also called as the firmware program. It starts execution whenever we switch on a computer. This program may be stored in read-only memory or erasable programmable read-only memory inside the system. And once the Bootstrap program starts execution, automatically it locates the operating system installed inside the system. After locating the operating system, it loads the operating system into the computer memory and the operating system starts execution. After starting execution, the operating system itself controls all the other activities of all the devices inside the system. So at first, when we start a computer, the Bootstrap program, also known as the firmware program, starts execution, and this Bootstrap program locates the operating system and it loads the operating system into the memory, and the kernel starts execution. And once the kernel is loaded and executing, it can start providing services to the system and the users. That means all the other activities inside the system will be managed by the kernel. Both the system programming level and the application program level, all the activities will be controlled by the kernel. And all the other activities of the system, once it starts execution, all the other interrupts, or the interrupts is the term that is usually used to denote any user activity. Whenever a user starts a new application within the system, it is denoted by the term interrupt. So at first, before any user application is processed by the system, it starts running the initial program, and this initial program loads the operating system, and once the operating system starts execution, the kernel takes in charge of all the other activities and controls all the activities of the system. For example, in Unix, the first process that is executed in any Unix operating system is the init process. And after initiating or after executing the init process, it waits for any other system calls. System calls or event that occurs whenever an user starts any other application, or whenever an input output device needs CPU attention. It informs the system through a system call. So after execution of the init process, it waits for any system call to occur. In case of any system call is initiated or it is informed through an interrupt. The interrupt may be a hardware interrupt or the software interrupt. Hardware may trigger an interrupt at any time by sending a signal to the CPU. Hardware interrupt may be some files waiting to be printed on the printer. So in case there may be pending files in the printer buffer, the hardware interrupt will occur. And in case of a hardware interrupt, the init process calls for another system call, which tells the CPU to wait until the pending task is performed completely. Usually the signal, the system calls or the interrupt signal will be sent to the devices through the system bus. And for software may trigger an interrupt by executing a special operation called a system call. It is also called a monitor call. Let's see in the figure indicates the timeline of the CPU processing and the processing of I/O devices. In the CPU processing cycle, when a user process is executing, when a user process is keep running on, at that time, if an I/O interrupt processing occurs, the CPU cycle will be kept idle until the I/O device performs its function. So whenever a function is performing or when the CPU is undergoing any activities, suddenly when IO device interrupt occurs at that time, the CPU waits idle until the IO device performs its activities. After completing the IO request, again the CPU starts with the program that was executing earlier. So this is the timeline which indicates the at any time of any interrupt, or if any interrupt occurs at any time, the system stops or suspends the current activity and process the interrupt, and then after completing the interrupt, the CPU starts again with the program. So when the CPU is interrupted, it stops what is doing and immediately transfers execution to a fixed location. The fixed location is the table which contains all the interrupt address, and all the interrupt service routine will be contained within the table. So fixed location usually contains the starting address where the service routine for the interrupt is located. The interrupt service routine executes, and on completion the CPU resumes the interrupt computation. The interrupt must transfer control to the appropriate interrupt service routine. The afterward method for handling this transfer would be to invoke a generic routine. Usually the system contains an interrupt specific handler, and when a system call occurs for a specific interrupt handler, it calls for the appropriate interrupt service routine. After completing the interrupt service routine, the transfers the control back to the CPU. So since only predefined number of interrupts is possible for a system, a table of pointers to interrupt routines can be used instead to provide the necessary speed. So these table of pointers, or the table of interrupt vectors, it contains addresses stored in as a table.